Got a bunch of material to go, so how's the volume? Is that in the back? Okay, cool. All right. This was originally about an hour-long talk, so I've chopped it down. I'm not going to cover stuff in as much nuance or all of the details that I want to get to, but I'll be available afterwards, so definitely please come hit me up. A little bit about who I am. Patrick Thomas. I work here at Netflix. I'm coming up on, or I'm just over the 3-month mark now. And the road that I got here informs a little bit of this talk. I was originally a developer, and then I started doing pen testing, and now I'm doing AppSec, kind of that security engineering type stuff. And the thought process there of that both people on the defender side need to be thinking about what attackers, how they look at those systems, and also an effective attacker these days really needs to be far more immersed in the actual technologies and sort of where the bodies are buried of these tools. So sort of to that extent, I want to take a little bit of check on the room real quick of who here sort of primarily considers himself a developer. Kind of like a quarter, third. Who considers themselves a pen tester? Couple of people. And then who's doing like AppSec or security engineering type stuff? Okay, so good mix. Part of this is going to be those people need to spend a lot of time talking to each other to be more effective at the things that they're doing. And then credit where credit's due. I originally developed this talk with a friend of mine, Alec, who you know everything about him from his Twitter handle there. So he's a cool guy. You should also follow him. Getting on to like, where did this talk come from? Two things put together defined this talk. This sort of line of logic of that there are all of these technologies. There are developer productivity technologies, there's automation technologies, there's deployment tools, and there's so many of them these days, and there's so much magic in there that it's very easy to not peek under the covers and take a second thought about what is that magic doing for us, and what is that power potentially handing to anybody who gets access to this tooling. And then the specific example from it was a pen test that I did in my previous job, my previous role, that just kind of got way too interesting way too quickly. Kind of the holy crap, what have we owned? So here's the setup. This was a typical service provider running a lot of services out there, doing some mobile stuff. They had done so many things right that we really wanted them to come out of this clean, but this left kind of only looking at application attack surface. Did one kind of obscure thing wrong, gave us code execution on a machine. We start looking around. We said, what is this chef thing? This seems like it could be important. We'd heard of it. We knew it was this like deployment technology, so this isn't so surprising. But when that's all you've got, that's the sort of the thread that you pull on. Pivoting to that, looking, we say, okay, we've got this big piece of infrastructure. No necessary surprise here. If you're deploying with Chef, you've got to have a Chef server. But and this dates this original talk a little bit. It was heartbleedable. So we got into this thing. We got JSession IDs or got session IDs rather, and start looking around. But this is where it started to go off the rails. This was essentially two mistakes in an organization that was doing a ton of things right, and we're looking at these things called data bags, which is if you have important configuration information, credentials, keys, those kind of things that you want to imbue onto a running instance, then you can configure them here and give instances that have this profile access to this kind of data. And that stuff, that's really kind of all the keys to the kingdom all in one place if you have access to these. And it kind of gets slowly worse and worse and worse as we're looking at this. And then pretty soon we realize that we have the keys to manage the Chef cluster themselves because Chef was managing Chef, which is sort of an interesting arrangement there. And basically remote code execution across every machine in their fleet. And where we were at with our sort of sort of slack-jawed expressions here was, how can a company that really only made 2 mistakes have given up everything? And that's a kind of power that you really want to delve into and care a lot about. And this was also a technology that we really weren't familiar with at the beginning of this engagement. So if this can't be the only one of these technologies, and also this can't be the only company. Is this normal? Is this what we should expect from a very DevOpsy, modern, automated deployment perspective? If so, this isn't the future that we want to get to. So that leads us kind of into the themes here. These are powerful centralized tools. Whoever has access to them has all of that power. So we need to care very deeply about sort of the promises they make and are they defensible. I talked about magic, this idea of when a tool does a lot of stuff for you, maybe you don't peek at it. If you're deploying from just a couple of random shell scripts that you had to hack up and sweat over every line, you probably have a decent sense of how they work. They may be crap, but at least you know what they do. Versus if you install some glorious magic deployment system, maybe you didn't look at all the bells and whistles in it. And a point, because I'm going to dump on a couple of things, I'm very bullish on the power of DevOps and modern deployment and immutable infrastructure and all those kinds of things as awesome security tools. But the point is that we want to make sure that we get these as right as possible and understand where that power is coming from. So kind of had material on a bunch of this, told you that I had to cut all of this down. So from all of these, I'm just going to talk about these here. If you're interested in some of the other ones, if you use them in your organization, hit me up afterwards. There's other stuff. And I'm not going to be able to cover this in as much depth, so I will skim over a couple of things. Start off with Jenkins. Hudson Jenkins, hands up, familiar with it, use it? Good, everybody. Realistically, if you didn't put your hand up, you probably use it somewhere. It is the controller. It is the heart of sort of modern deployment infrastructures. It's the place where we go from messy developers doing messy code type things to beginning to put things on the path to going out to deployment. So we should care very deeply about what goes on in our continuous integration server and who can do what there. So for each of these, I'm going to really quickly hit identifying, attacking, and defending, just to make sure that everybody gets one. So the identifying is coming a little bit from the pen testers or the external adversaries perspective where, hey, does this organization rely on this technology that I might be interested in? Jenkins is phenomenally helpful in so many ways. There's really good reasons that people use it, but one of them is advertising its existence. If you're in an environment and you're a pen tester and you start looking for any of these telltales, you'll be able to quickly find Jenkins. It responds with X-Jenkins headers. It has all of these ports, but these down here are delightful. You don't even have to scan for it. You don't even have to bust out Nmap. If you can do a DNS service discovery and broadcast out, it will tell you that it's there. So you can very quickly discover these things on an environment. All right, attacking. This one is probably, I think, the most powerful one and the one that surprises people the most of Jenkins absolutely has remote code execution built in as a feature. Out of the box, good to go, let's rock. Because that's a useful thing to have on your build server, but many people have never heard of it, many people never use it, many people don't realize that that's a thing. If you go to, on your Jenkins server, /script or /text and post to that, you'll get code running. And of course, there's a Metasploit module because there's a Metasploit module for everything. Also, any build configuration can put shellcode in there. That will run somewhere, not necessarily on the server, but that will get run somewhere. You can put all sorts of things in there. There's also important details in these, which if you're not looking to write but read, people will include all sorts of stuff in these details. Sometimes passwords that they don't want baked into the code, but that's needed in the build. Those sorts of things. So what does that /script endpoint look like? It takes Groovy, which not many people write Groovy these days, but here's a great opportunity to write some Groovy, and you can run it. And on Windows, Jenkins installs as system by default, which I do not know why, but there you go. So anybody who's doing sort of pass the hash type stuff or Mimikatz, any of those, Jenkins, Mimikatz, domain admin, done. And no CSRF token. So this is CSRFable. If you know the Jenkins server in a company and a little bit about it, you can execute code on Jenkins through people's email, which is pretty awesome. Just recently, and in the trend of things are getting better and security tools are getting smarter and caring very deeply about this, modern installs of Jenkins have the CSRF stuff turned on by default. It does support it. Previous older versions didn't, and when you upgrade Jenkins, if you're coming from an older version, it doesn't have that flag set. So if you've got a Jenkins server that's been around for a couple of years, maybe go check that config. You probably don't have that setting. So quick, simple CSRF. Also something that surprises people because most of us spend our time as authenticated users on systems, and this is where seeing a little bit of the attacker's perspective helps. If you're not logged in, the default behavior for Jenkins is to allow browsing of workspace artifacts. This is actually super important for fetching build artifacts and doing other deployment stuff. But it means that if you're putting important things into your built artifacts, such as config files or passwords in code, which we shouldn't be doing anyway, but does happen, any of those kinds of things, unauthenticated users can browse through these, and if your source code is in Java or Python or Ruby or one of those languages is very easy to reverse, then unauthenticated access to Jenkins is as good as access to your source repository. And that, I think, surprises too many people. Then they're getting better at this now, but also something that surprises people is that slaves can send commands to the master. So that is command execution on the master from any kind of slave that you have. The example here being, an XP machine or something that that other people have admin access on, who you might not give admin access on the master to. That's a transitive relationship. It does honor that. Modern versions, you can lock this down a little bit more, but again, it's not the default. Defending. Jenkins, I think it's 2 and more, has built in a bunch of these different security things, but so that they don't break anything, if you're upgrading, they're not going to be on by default. So you should definitely add these. There are more complex authentication mechanisms than the default ones that come out of the box. So definitely look into those. Enable CSRF tokens, and then also check your plugins. You can have a totally up-to-date Jenkins and a whole bunch of really old plugins. Okay. Docker. Who uses Docker? Okay, decent number of people. Would have expected more. Okay. I think the important thing is many people will treat it like a VM. It's not a VM. It's freaking magic. It does so many cool things that can be VM-like, but it's not the isolation that you want for untrusted processes or for processes for tooling that you wouldn't necessarily trust. If you're pen testing, if you're getting access to a box and trying to say, hey, is this involved with Docker? There's a couple of telltale files and processes that you can look for. If you think that perhaps you might be on a Docker host, there's these telltales to look for, or if you want to prove to yourself that you've broken out. And then finally, if you're nmapping, scanning for Docker registries, that port 5000 or that curl, that's how you talk to a Docker registry and get it to come back and say, yep, that's what I am. Attacking the container breakouts. I said they're not VMs. So it's really important to realize that any syscall is potentially a way out of that container. There was the one called Shocker in 2014. There was an easy way to drop out. We all heard of Dirty Cow. That's a little bit more recent. Any of these kinds of things that access system calls are potentially a way to violate that magic trick of running in a machine but not in the machine. If you're on a machine, some ways of passing credentials or important information, configuration information into a machine, environment variables, those kinds of things. So if you're pillaging around, make sure to check for those. Another thing that I find surprises people is that the Docker user is as good as root on a machine. So don't ever get cute or clever about letting people pass command line parameters or sort of arbitrary things to either the Docker command or as the Docker user, because this is sort of a trivial demonstration of breaking out of that using the abilities that you have for the Docker daemon. Originally, I had Docker defenses, but this slide got too long, and I think the larger point is that Docker defense is a huge topic right now. So I've got to slash through the slide so that I don't leave it as, yeah, this is all you need to do. It's a massive topic. There's a lot of things that you definitely want to start thinking about, but this is definitely not the end of the story. Getting out of Docker is, if you're running in Docker in AWS or something like that, these sorts of looking around once you're in a machine, looking around for these kinds of keys, either hard-coded or in configuration files and environment variables, potentially lets you immediately escape from a Docker container and get far more access to the rest of the environment. This is essentially duplicating the chef scenario that we had at the beginning of the day of I was in just an instance, but now I have ability to administer the larger cluster. So these shouldn't necessarily be available, but if they are, make sure that they're constrained. I was having some discussions with people earlier today, making sure that this is still true. If this is inside of a Docker container that we're hitting, and you have something like a XML entity injection. Familiar with XML entity injection? Okay, not enough hands. It's really sick, especially if you deal with XML. This can just ruin a day. But if you can XML entity inject into a Dockerized application, then you can turn around, request this URL, which is the AWS local metadata service, which will cough up credentials that instance should have access to. And the important thing is, although we're going into a Docker container here, we're talking to the local metadata service on the host. So this is, in essence, a Docker breakout without ever touching Docker. And I just actually learned this very recently. This essentially works on Kubernetes as well. By default, it puts tokens that are available to the service accounts, maps those into a directory on the entire pod. So there's a tremendous story, this is how it came on my radar, of the B-Sides San Francisco CTF that just ran a few months ago. A contestant in the CTF used this trick to own the entire CTF, and there were a couple of really good security people running it, so I think this is going to surprise people as well. So wrapping back together on our themes. These are powerful tools. These are good things that we should use that let us do lots of things very quickly and consistently and reliably. But if attackers get a hold of them, then they have all of those capabilities as well. So put all of our eggs in one basket, but watch that basket. This is the magic part. Just make sure that we understand all of the different things the tooling is doing for us. Read the manuals, look at the sorts of things that it exposes, and then yeah, do more of this. Just do it carefully. Skip over this, but this is sort of a where the bodies are buried if you're doing remote file includes or things like that. I've started building up this list. If you care about this kind of thing, come hit me up afterwards. Other than that, there's my time. Thank you all.